Hello, and welcome to our introduction to Six Sigma, and specifically the information and knowledge needed for the Yellow Belt certification. Six Sigma is a popular and effective methodology to assist businesses to improve products and processes. The body of Six Sigma can be deep and wide, and depending on your particular product and the industry you're in, the use of the many tools will vary. If the body of knowledge of Six Sigma were a large pool 12 feet deep, we will be dipping our toes in the pool. Many of the concepts we will discuss today may be new to you. You will learn new definitions, terms, acronyms, terminologies, and concepts. If you find this interesting and profitable, we offer more in-depth courses in Green Belt and Black Belt certifications. Without further delay, let's get started. Here is the course outline for reference. Evolution of Six Sigma. What is Six Sigma? Goals of Six Sigma. Six Sigma approach. Why do organizations adopt Six Sigma? Six Sigma mathematical interpretation. Roles in Six Sigma organization. Key stakeholders. DMAIC cycle. We will begin with the first chapter, Evolution of Six Sigma. The concept of Six Sigma evolved progressively over a period of 2 decades in step with concerns of organizations worldwide for quality, value creation, and customer delight. The phases of this evolution can be identified concurrent with the emphasis placed on these 3 critical business parameters. The timeline can be approximately summarized as follows. Now we will move on to the next chapter of What is Six Sigma? As far as the definition of Six Sigma goes, it is a data-driven, customer-focused, and results-oriented methodology which uses statistical tools and techniques to systematically eliminate defects and inefficiencies to improve process. The salient characteristics of the Six Sigma methodology are: it is customer-centric, it is product and process focused. Six Sigma projects are data-driven and fact-based. Six Sigma implementation leads to breakthrough performance gains. It leads to structured improvement deployment. Six Sigma stresses validation through key business results. Now we will look at the goals of Six Sigma. The most prominent goals of Six Sigma are enhancement in customer satisfaction, elimination of defects, improvement in yield, reduction in variations, strengthening of the bottom line. Here's an example to illustrate the goals. GE's Medical System Division, GEMS, used Six Sigma design techniques to create a breakthrough in medical scanning technology. Patients can now get a full body scan in half a minute versus 3 minutes or more with the previous technology. Hospitals can increase usage of their equipment and achieve a lower cost per scan as well. So what is the Six Sigma approach? Six Sigma approach is to find out the root causes of the problem, symbolically represented by y equals f sub x. Here, y represents the problem occurring due to causes x. Let's move on to the chapter on why organizations adopt Six Sigma. Organizations embrace Six Sigma because this approach systematically and measurably enhances the value of the organizations by making them competitive, quality conscious, customer-centric, and forward-looking. Some of the benefits that the organizations derive from Six Sigma initiatives are waste prevention, defect reduction, cycle time reduction, cost savings, market share improvement. In our next chapter, we will learn about the mathematical interpretation of Six Sigma. Sigma, represented by the Greek alphabet letter sigma, this letter stands for standard deviation from the mean. Six Sigma represents 6 standard deviations from the mean, where USL, upper specification limit for a performance standard, any deviation from this is a defect. LSL, lower specification limit for a performance standard, any deviation below this is a defect. Target, ideally, this will be the middle point between USL and LSL. Details will be provided in our Six Sigma Green Belt and Black Belt course. Process standard deviation, sigma, should be so minimal that the process performance should be able to scale up to 12 sigma. 6 sigma each on either side of the origin on the x-axis, within the customer specification limits. Let's take a look at a table illustrating the sigma level, defect percentage, and resultant situation for different industries. Sigma level 3, 6.6807%, 7 hours of no power supply per month, 15 minutes of unsafe drinking water per month. Sigma level 4, 0.6210%, 500 incorrect surgical operations per week, 20,000 incorrect medical prescriptions per year. Sigma level 5, 0.0233%, 1 wrong landing of airplane per month, 200 letters lost by day in the mail. Sigma level 6, 0.00034%, 1 minute of unsafe drinking water supply every 7 months, 1 hour of no supply once in 34 years, 1.7 incorrect surgical operations per week, 68 incorrect medical prescriptions per year, 10 letters lost by month in the mail. It is important to note that as the sigma level increases, the defect percentages decrease, which improve the efficiency of the process. Moving on, let us look at the roles in Six Sigma organization. The major roles are as follows: executive leadership, champion, master black belt, green belt, project team, and team members. Let us learn about each role in detail. First, we will consider executive leadership. This role includes project sponsors and process owners. They create the Six Sigma vision for an organization. They are responsible for ensuring that everyone in the organization understands the vision and all work with unity of purpose to realize it. The next role under discussion is champion. Champions are selected by executive leadership or senior champions. They organize and direct the initiation, deployment, and implementation of Six Sigma throughout the organization. They ensure that Six Sigma is properly implemented in the business activities of the organization. Champions can be either deployment champions or project champions. Next in line are the Master Black Belts, who are in-house experts selected by champions. They manage project selection and human resource training with the help of champions. They train black belts and green belts in Six Sigma implementation. Next are the black belts. They apply the tools, techniques, and knowledge of Six Sigma principles to a given project of an organization. They are responsible for accomplishing the tasks entrusted to them by champions and executive leadership. They dedicate all of their work hours to Six Sigma implementation. After black belts, we have the green belts. These individuals implement Six Sigma while discharging their other assigned duties. Green belts have fewer Six Sigma responsibilities than black belts and master black belts. They dedicate only a part of their work hours to Six Sigma implementation. The last rung belongs to the project team. These are team members who work on the Six Sigma project. It includes the project manager as well. Project team members need not be a green belt or black belt. Now let us see who are the key stakeholders in a Six Sigma project.
The first stakeholder is the customer. Customers are very important stakeholders whose requirements have to be considered throughout the project cycle. Then comes the employees. These are the people involved in the Six Sigma initiative in the organization. Next are the suppliers. They are people who provide inputs to the process. Finally, we have the end users. They are people who actually use the product or service. End users can also be customers.
In the next chapter, we will look at an overview of DMAIC. DMAIC is a data-driven Six Sigma process for improving existing products and processes. The DMAIC process should be used when an existing product or process requires improvement to meet or exceed the customer's requirements. This initiative should be consistent with the business vision, strategy, and goals of the organization.
The examples of companies using DMAIC methodology are GE, Motorola, and many others. GE uses DMAIC to reduce invoice defects and disputes by 98%, speeds up payment, and creates better productivity. Let us see what exactly DMAIC stands for. D stands for define the problem. M is to measure the outcome. Y to determine the current process performance baseline and validate the measurement system. A is for analyze, identify X's, root causes of the defects, variation sources. I stands for improve the process by eliminating defects. C means to control X's for sustained performance. Now we will look at each of these phases. Each of these phases has inputs, tools, and outputs. The inputs of the define phase are need for a Six Sigma project, executive management sponsorship. The tools used in this section are organization hierarchy, high-level process maps, high-level Pareto charts, idea generation and categorization tools. The outputs of the define phase are project charter, established metrics, problem statement, roles and responsibilities. The next phase is measure. The inputs here are project charter, roles and responsibilities, problem statement, stakeholder requirements, established metrics. The tools recommended for this phase are data collection tools and techniques, detailed process maps, cause and effect diagrams, flowcharts, brainstorming, statistical distributions, probability, gauge R&R study. The expected outputs are well-defined processes, baseline process capability.
Hello, and welcome to the second part of the course on Six Sigma Yellow Belt. In this module, we will discuss the 7 basic quality tools, the types of data, and DFSS. The 7 basic quality tools are tally sheets, flowchart or process map, histograms, cause and effect diagram, Pareto diagram, scatter diagram, and control charts. Before we get into the details of the 7 basic tools, let us become familiar with the concept of data types.
Data can be broadly categorized into 2 types. The first type of data will be continuous data, and the second would be discrete or attribute data. Continuous data are measurable by some physical instrument, and the value is continuous. It can be any number including decimals, but it does not need to be an integer. For example, weight, height, length, and density. Attribute data is countable and must be represented by integers. Attribute data are also classified as good or bad. For example, number of defects or defectives.
Having discussed the concept of data types, let us now have a look at the 7 basic quality tools in detail. The first tool that we will discuss is tally sheets. Tally sheets are very important tools for data collection.
Inputs gathered from tally sheets can be used to create Pareto diagrams, fishbone diagrams, etc. The purpose of tally sheets is to ease the compilation of the data in such a manner that they can be used or analyzed comfortably. They are a simple and convenient recording technique for collecting and determining the occurrence of events. They are constructed with each observation to give a clearer picture of the facts. What are the steps involved in creating tally sheets? The first step would be to determine the objective by asking questions such as, what is the problem? Why should data be collected? Who will use the information being collected? Who will collect the data? The second step would be to decide the features, characteristics, and items to be checked. The third step would be to create a tabular form for collecting data. Traditionally, the features, characteristics, items, type of defects, etc. are listed on the left side of the check sheet. The fourth step would be to collect the frequency of data for the items being measured. Record each occurrence directly on the right side of the check sheet as it happens. The fifth step would be to tally the data by totaling the number of occurrences for each category being measured.
The next basic quality tool that we will discuss is the histogram. Let me describe what a histogram is and the information it shares. A histogram is a visual representation of variable data. It organizes data to describe process performance and displays centering of the data and the pattern of variation. It demonstrates the underlying distribution of the data. A histogram can be used to check whether or not the data is normally distributed. It provides valuable information for predicting the future process performance, and it helps to identify whether the process is capable of meeting process requirements.
What are the steps involved in creating histograms? The first step is to collect the variable data in a table. The next step is to ensure that all the measurements are in the same unit of measure. The third step is to arrange the data in ascending order, such that the minimum and maximum value can be identified. The fourth step is to choose some suitable interval length of uniform size. The fifth step is to use a check sheet to count the number of observations corresponding to each interval. The number of observations for a particular interval is said to be the height of the interval and displayed as vertical bars. A sample diagram is given here where the raw data is displayed in the form of a histogram. We can see the shape of the underlying distribution. Some of the important aspects to be considered when studying a histogram are, firstly, location of the mean of the process. Secondly, spread or variation of the process. And thirdly, shape, pattern of the process.
The third basic quality tool we will discuss is the flowchart or process map. What is a flowchart or process map? It is a graphical representation of processes in an organization, displaying the sequence of tasks performed and their relationships.
It is a prerequisite to obtain an in-depth understanding of a process before application of quality management tools such as FMEA or SPC, etc. Process maps are progressively elaborated. Early on in the Six Sigma project, a high-level process map is defined showing major processes. This is made more explicit and detailed as the project team develops a more and complete understanding of all the processes. Standard symbols are used in the creation of process maps.
What are the benefits of a process map?
First, it helps clarify several process steps and process flow which may not have been understood clearly before. Second, it shows problem areas, unexpected complexity, redundancy, idle time, unnecessary loops, and where simplification may be incorporated. Third, it visually shows the various alternatives possible and helps in selecting an appropriate solution. Fourth, it helps all members of the team gain appreciation for the work being done by others in the team. Fifth, it compares and contrasts the actual versus the ideal flow of a process. And last, it can be used as a training tool.
Next, I will explain and show you the symbols used in process maps.
The first symbol is a rectangle. The rectangle represents a process step or action taken. Each process step has one or more inputs, does some activity, and creates one or more outputs. The next symbol is a diamond. The diamond represents a decision step. Options from possible alternatives is selected depending on the input to this step. The third symbol is an oval. The oval represents the start or stop of a process map. It is also used to depict if the process map continues on another page. The fourth symbol used in a process map is an arrow. The arrow represents the direction or flow in a process map. Now that you know the symbols of a process chart, what are the steps involved in creating a process map? The first step is to put together a cross-functional team who have knowledge of the process and appropriate subject matter expertise to create the process map. The next step is to define the process and its boundaries, including the start and stop points. The third step is to describe the stages of the process in a sequential manner. The fourth step is to assess whether the stages are in correct sequence. The fifth step is to draw the process map using the conventional symbols learned earlier. And the last step is to have it reviewed by people involved in the process to check its accuracy. Let me explain the as-is and to-be process map. First, try to find existing process maps which may already be in existence in the company. Next, map all the as-is high-level processes as they now exist. This will create an awareness within the team about the processes in existence currently, and that all team members understand the contribution of others. This is the as-is process map. Then, ask the cross-functional team to study the process and identify opportunities for improvement. And finally, based on the inputs from the cross-functional team, map all the to-be processes. This is the to-be process map. Next, we will discuss the cross-functional process map. When more than one function or departments of an organization are involved in a process, which is very likely in general, then we need to create a cross-functional process map instead of a simple flowchart. It is the simple process map along with the various functions displayed on the left side of the diagram. The sequence of tasks are mapped in such a way that they correspond to the respective functions. It may be possible that some tasks are performed by two functions. These tasks must then be displayed in such a manner that they will fall in both functional zones. Let's look at an example.
The fourth basic quality tool we will discuss is the cause and effect diagram. What is a cause and effect diagram? It is a graphic representation of the possible causes for any particular problem under study.
This tool was developed by Kaoru Ishikawa in the 1960s to determine and break down the main causes of a given problem. This tool is employed where there is only one problem and the possible causes are hierarchical in nature. This diagram is also known as a fishbone diagram because of its fishbone-like structure, and the Ishikawa diagram. It gives the relationship between quality characteristics and its factors. It focuses on the causes and not the symptoms. A cause and effect diagram is usually created by a group of people who have knowledge of the process and understand the problems in the present system. It helps in finding the root causes of the problem and in generating improvement ideas. It clarifies the understanding the team has regarding the process. If an Ishikawa diagram does not show an appropriate level of detail, it indicates that the team has a superficial knowledge of the problem. Therefore, additional study of the system or involvement of subject matter experts is required. The steps involved in creating cause and effect diagrams are: first, the effect. A specific problem or quality characteristic is the head, and the potential causes and subcauses of the problem or quality characteristics make up the bone structure of the fish. Therefore, write the effect of the problem in a box to the right-hand side. Second, draw a horizontal line from the left